Hello, welcome back to this part 4 of this context engineering. In the last three parts, we discussed about what is context engineering is all about, what is the context and what are the challenges with a large context. And then we saw the two context strategies called context to loadout and context quarantine. And in this session, we are going to see third context management strategy called context offload. We'll see what is context offload is all about. We'll understand what is agent memory. We'll see them live in the action with a code walkthrough and a demo. With that, let's get started. Now let's talk about the context offloading. So this is one of the most important strategies in context engineering. First of all, what is context offloading? Context offloading is about freeing up your LLM's context window by moving large terms or maybe rarely used information into an external memory. It could be a database, or it could be a vector store, or it could be something like in-memory store also. So this makes sure that model isn't overloaded with unnecessary details every time you ask the questions. So why first of all, let's look at what problem this is actually helping. So the problem we discussed in the last couple of sessions is that LLMs have a limited context window, right? Even if you think that context window is like really big, like Gemini, 2 million tokens, you still cannot by dumping everything in large context. We'll see what are the challenges we might face, like context poisoning or context confusion, right? So if you keep stuffing them with your past conversation history, the tool's output, or any research notes, the context becomes cluttered. That makes the model slower, more expensive to run, and more prone to error. In other words, too much context equals to the inefficiency. That's what we discussed in the last couple of slides. What are challenges will have even if you have too much context. So the solution is simple. You offload. Just like you cannot carry all your notebooks to every class student, right? If suppose if you are taking a notes, you are not carrying all your notes like every meeting. You take only the notes required for that meeting, right? Similarly, the solution is simple. You offload them. Instead of keeping everything inside the model context, we move long-term or rarely used information into an external store. That could be something like a ZEP, a memory store, or it could be something like a Pinecone or any traditional database. So when model needs that information, it can pull that back information selectively, very important, not all of them. So how does a typical workflow looks? So user asks the question, the agent offload old or rarely used context into the external memory. When needed, agent retrieves only the relevant pieces. Finally, LLM responds using a smaller, more context window. The way the model always works with the most important data. Nothing extra, nothing wasted. So what is the benefits we get out of this? One is that efficiency. So we have seen that a smaller context window means lower cost, right? That's what we have seen in the last couple of sessions, where we have seen the Langsmith when we say the smaller context means lower, less number of tokens and lower the cost. And then speed, you get a faster response since the model isn't scanning through the unnecessary informations. And most important thing what I feel is the focus. The model only sees what matters, which improves accuracy. It is just like any human being. If you're going for a meeting, if you want to be really focused, you want to look at only the meeting notes relevant to that particular meeting, not all of them. That's what we are doing here. So to summarize, context offloading helps agents to stay sharp and then cost effective, and then most important thing, being focused on the task at hand. So we just saw why context offloading is essential. Now let's take a look at how we actually implement it in an agent. So there are two main patterns we use, something called session scratchpad and then a persistent memory. So first let's understand session scratchpad. So this is a temporary workspace, a lightweight place where agent can jot down thoughts during a single conversation. So think of it like you are going for taking a notes in a notebook. Technically, it lives inside the agent state. as an extended field. So it is accessible while the conversation is live, but it disappears in the session when session ends. So we typically use two tools here. One is something like a write scratchpad for storing quick notes, and read from scratchpad to retrieve them when building the final answer. So this is something like a one-shot reasoning or research agents or anything where the memory only last for few turns, not persistently. Now the persistent memory, this is designed for a long-term recall. It is means across sessions. You can log out, log in, you can come back for 2 days, you still see the sessions, and across the threads and even across users if needed. So instead of dumping everything in the prompt, we store useful facts in a memory store. That might be a key value database, a vector index, or some tools like a ZEP memory, which I'm going to show you after this, like what ZEP memory is all about. So we store items using something like a namespace key like user session or a topic. We attach a metadata like timestamp or some other information. So this pattern gives the agent a durable brain. It can accumulate findings over time, reuse prior research, and personalize response without bloating the prompt. So in summary, use Scratchpad for now if you want in this session, but for persistent memory for later retrievals. So together, the combination of Scratchpad and the persistent memory makes the agent stay efficient, thoughtful, and scalable without dragging unnecessary information into the prompt. So that's what about the two offloading pattern. Now we'll see them in detail and how to implement a scratchpad, what is the persistent memory. We'll see different patterns in this. Now let's take a closer look at the memory in AI agents. First, let's see the big picture and then we'll go to each one of them. So broadly speaking, there are two major types of memory that every intelligent agent relies on: a short-term memory and a long-term memory. So short-term memory is fast, lightweight, and highly focused. It stores only what is needed for the task at hand. A recent user input, maybe a tool output, maybe the last 5 messages. You can think of it like a scratchpad or a RAM, quick to access but just as quick as to disappear. Once a session ends, the context window resets, it's gone. Long-term memory, on the other hand, is what gives agent sense of continuity. It holds on to facts, patterns, preferences, things that stay relevant over time. This memory evolves. It grows as agent interacts more, learns more, and experiences more. And inside long-term memory, we can actually break it down into three functional types. One is episodic memory for recalling specific events, semantic memory for storing any facts or maybe factual knowledge, procedural memory for remembering how to perform a task. So each of these plays a different role in helping agents act, reason, and also adapt to the changing information. So to summarize at high level, this is what you should think about. Short-term memory is for the focus. Long-term memory for the agent to learn, remember, and grow. Right? So when you start combining these things effectively, that's when your agent goes from being just one tool to something which is smart, stable, and actually useful over time. Next, let's talk about episodic memory. We are also going to see a quick demo of this using ZEP. So just like humans, AI agents benefit from being able to recall specific past interactions, not just facts or skills, but actual episodes of what happened, when it happened, and who was involved. So the kind of memory lets agents say for example, you asked about Dallas weather yesterday, or maybe last week you told me you are a vegetarian. Should I keep that in mind for today's recipe? That's what you actually see when you're talking to ChatGPT. If you keep talking to it, over a period of time it knows the kind of person you are and what are your preferences, what questions you asked. It can connect that with the current question you are asking also. So this is what we call episodic recall, pulling up a specific past event and using it in the current interaction. Actually, in fact, we are going to see this in action in the demo. So let's take for example, the demo we are going to have is a nutrition expert agent. Okay, on the Monday, user can come and say, I had a oatmeal and berries for breakfast. The agent stores it as an event, not a generic fact. Okay, but on Wednesday, when the user asks, how was my breakfast pattern looking this week? Because the agent has got episodic memory, it can look back across the last few sessions and say, you had a oatmeal and berries on Monday and smoothie on Tuesday. Both are great high fiber options. So that's not summarization, that's a retrieval of specific past events that agent remembers happened and when it happened. So behind the scenes, what happens is agent stores each interaction as a structured memory, something like what I shown, like a simple, it could be simple JSON. You say type is equal to meal log, the user ID, the timestamp, and the contents. So the memory can be indexed by time, topic, or user and retrieve on the demand. Either we can use in LangGraph or LangChain. This typically stored in long-term memory store backend like a vector store or maybe key value store or maybe something like a zip memory store, which I'm going to show you after this. The agent retrieve based on filters like last 7 days, and something like a zip memory, they can build a graph of the whole user interactions. Like every time you interact, it can build that the memory graph so that it can relate things like, okay, for example, I told about my yesterday's lunch. I went to Dallas yesterday. I had a lunch. Then after lunch, I had some some stomach upset. Then I ate this much. I ate this food. It knows that this food at this restaurant, maybe this happened. So it can actually link all these things. So when you are actually asking about a restaurant or a food next time, it can actually build that knowledge graph and then say, hey, this is what happened for you. So it can collect that. It has got the context which is not very static, the context which is related with the different events the user is asking. We'll also see that in the action. In the next slide, we'll see we'll see a quick demo of Zep, and we'll see a full demo of Zep and how it in action when I show you a nutrition expert agent at the end of this. So we'll see the Zep memory. We are going to see Zep memory also in our demo. This is a memory where you can use it to build the agent memory. The good thing about Zep memory is that as and when you are talking to the customer, it will to the agent, it will actually build that a graph behind the scenes for every conversation you have. It will update the facts. It will identify the entities. So when you actually want to pull the information during your agent, it's just like when you get that information, it has not only it has got that the facts, the context, the relationship, everything is baked in. So let's see that actually how it works. Let's go to the playground here. Now you can see that every time user is talking to this one, it is actually building this a graph. Okay, you can see that now we have a user is asking, I am looking for a Taylor Swift concert, tickets in New York, I'm a huge fan. Now if you see, it has built Sarah as a user, it has built the entity, some email and everything. Let's keep talking to this particular agent and see how it actually builds. Now I will add what is the best seating arrangement. Not everything it may not add it to the graph. Some it might skip to adding to the graph. Let's see which of them. So for example, this one, it has skipped adding to the graph. Now let me ask for, do you have any pre-sales? And of course, the AI is giving a response. When you give the response, you can see that facts and entities. Okay, the user, this is basically agent, even though, of course, this is the context passed to agent. Okay, so what context it has passed every time when you ask this question, do you have any pre-sales, code for upcoming concert, the Zep is able to pull the facts and entities and pass it as a context to the this one. So for example, now you can see that it has passed this facts as about, asking for about your targeting monkey. User has this ID, and it has got some summary, and then it has got name, what is who is Sarah, and then about this user ID. It is giving, all this details, and it also builds that user information here. Let's see what is there for the user. User is entity here, and Sarah Smith, you can see that there's one node, and you can see Sarah has one more node as built. It is actually giving the details about the Sarah node here. So like this, it is actually building this graph rag of of user conversation. And then for example, even if we enter anything, then it knows that this user is interested in this concert. This concert is happening in this particular Madison Square Garden, and Taylor Swift is giving the concert is happening, and then you have all this conversation. The beauty is that every time you ask a question, it is passing these relevant facts and entities to the agent. That means agent is having the context of all the previous conversation related to this question. Of course, there are a lot of information, but it is only pulling that relevant information, right? Something like AI wellness companion. You can also see the one more example also here. You can play around with this one. You can see that I notice your I'm feeling really stressed and lately having trouble sleeping is added to graph. Some it will skip adding to graph. Okay, now we can say what should I eat for my lunch here, and then it is processing. It is maybe you can see here now when it is actually want to answer this question, it is getting this context from the Zep. Now this is giving the facts and the entities for this particular question, and it is giving that context to the and then there is a graph rag being built here. So it's something like a yoga, and then let me see something like lunch. Okay, what is there in the lunch here? Some information about the lunch, protein, something like maybe user asks some question to some protein. So like this, something like about the user feeling stressed of having trouble sleeping lately, analyze the influence due to busy day ahead. Basically, it is adding all the information. So depending upon that's why when it is asking for give me I have a busy day, what should I eat for lunch, it is pulling that information. Okay, you can see that Alex performed yoga, the strength and progress, it is giving all the information like all the information related to Alex, like what Alex has done in the last couple of days. It is giving that information, and then using that information, the response being generated. We'll see this in action when we build the actual demo of the nutrition agent. Then you will better understand how this graph, the knowledge graph is built. So now let's see what is semantic memory. So semantic memory is what helps AI agents to recall some general facts, not tied to any specific user, conversation, or the moment in time, right? So for example, say you have built a travel assistant agent. Now imagine a user asks a question, can I fly from Dallas to Rome? And user B is asking the question, what is the capital of Italy? In both cases, the agent retrieves the same fact. Rome is the capital of Italy. It didn't learn during the session. It wasn't something user told it before. It came from a pre-trained knowledge base or a RAG system backed by your internal database, or it could be some Wikipedia or some official data sources, right? So semantic memory is not tied to specific user, doesn't rely on recent chat. So how do you pass when it could be a RAG tool? That means when user is asking about some information, you could add a RAG tool. That RAG tool can actually retrieve the ground truth related to this particular user question from the RAG tool, from the semantic request vector database, and then pass it as a context to the agent. And maybe that could be there only for that session, only for that question. That context is relevant. It is not relevant beyond that question. So next talk about the procedural memory. Procedural memory is what allows an AI agent, or to remember the steps in the process. So again, take going by the same example of booking a flight. So it remembers sequence of action. First ask for dates and destinations, then search for available flights, then present the option to the user, finally confirm the booking. So this is different from other types of memory because it is action oriented and repeatable. Once the agent has learned the procedure, it can reuse those steps again and again for the future interactions. So, procedure memory is like a toolbox of reusable skills. It's consistent across users. It is not user based, user specific, type of memory. And what is important is the agent can learn once and can repeat this again and again without redoing the sequence of things again. So in short, procedure memory is what enables an AI system to reliably carry out very structured tasks like booking a flight, or maybe doing some research, or maybe closing a ticket. So it could be anything. Wherever you have very structural procedural task involved, you can use a procedural memory so that agent can remember this, so that when you are actually asking agent question, you can pass it as a context. Hey, when the question is this, you need to book the flight first, you need to search for present the options, when the user confirms, do this. So you pass all this procedure as part of the context to the agent. So to summarize here, we discussed about episodic, semantic and procedural. Episodic stores past user specific experiences, which is typically by ZEP or LangGraph memory. For example, where did I book last week, then stored as a chat history, the key or node value pairs as a graph rag, as we saw. Then a semantic memory, general facts and knowledge, typically by RAG tool for agent. And then a procedural memory, which is a skills, instructions or workflow. You can use something like a scratchpad. Again, you can use ZEP also, you can use Redis type of tools where you can store the procedures. So this is about a summary of the agent memory. Next, we are going to build an agent, and we'll use both a scratchpad and ZEP memory to build that agent, and we'll see how we can actually offload the context when user asks a question, or we can retrieve the context when from the memory. So next we are going to build a nutritionist agent, okay, where the purpose of this agent is user can log the information like, hey, I have, this is my for my breakfast, lunch, dinner options. They can also log information about something like their weight, maybe something like their sugar readings, maybe their BP, maybe any other complaints they are having. And then they can, or they can also do some research on, ask some doubts about, hey, can I eat this, can I eat that, like that, some kind of question they can ask, and they can ask it for lunch or dinner, breakfast options. It remembers every interaction. It builds that knowledge graph about interactions in the behind the scenes in a ZEP memory, and then depending upon the user question, that is passed as a context to the user. So this is built using LangGraph and ZEP. So I'm first going to walk you through the code, and then we'll see that. Okay. So first, these are all imports. We are using ZEP Cloud here. So because I am instead of having all the local installation, I'm using ZEP Cloud. Again, this is all Langsmith. So if you want to have the, you get from the log all the interaction to Langsmith, you can do that. We'll also see the Langsmith UI in the end. And then this is our ZEP. You need an API key for ZEP. Okay. You need to get the API key, and then you have to put them in .env file. So this is basically a state object. We are having a simple scratchpad here to store all that temporary memory, which is the information agent is having in between. So I'll be using a DeepSeek as an LLM here, so that this is a method to call DeepSeek. We are using DeepSeek client here. This is simple. With temperature, we are keeping it as 0. Now we are using Perplexity for all the research. So user asks a question, hey, can I eat mangoes, if, for a diabetic, for someone with diabetes, or maybe is red wine is good for health, like that type of questions if you want to ask, they can use, we will be using Perplexity for this. So any user questions will invoke that call Perplexity search API. So these are two tools you're having. And then get daily thread, because every time when we have interactions required, we are going to create a thread in the Zep memory. I'm going to show you that. And then this is some simple utility method where, depending upon the user question, we want to classify that question, whether he's asking about a meal category, or is he asking about the weight or glucose, blood pressure, exercise, some symptoms, or something general. Okay. And then this is some simple method to make sure that the user we are trying to create is, because every time you use Zep, you need to get the user in Zep, and you can use only that user. So we'll make sure that that user actually exists. If it doesn't exist, we'll create that user, and then we'll make sure that the thread exists. Otherwise, we'll create a thread. So now the first thing we do when user asks a question, we have one node which will do the intent analysis. Like, what is this user is asking? So we want to categorize the intent into three parts. One is that health log. That means user is logging some health data like their meal, their weight, their blood pressure, their glucose, symptoms, etc. The other could be nutrition lookup, where user asks for nutrition information. And then recall or compare, user want to analyze their past data patterns or some get recommendation based on the health history. And then it returns this JSON. So for example, this is what we are also giving some examples, some future examples to user. To the prompt, there's I ate rice for lunch. The intent is health log, right? So my weight is so and so. Then the intent is health log only. And then is mango good for diabetes? There is a nutrition lookup. So what should I eat for protein is what? Analyze my meals today is again recall compare. So this particular node will identify the intent of the user question. Okay. Then we pass this prompt to the DeepSeek. DeepSeek will return what is the intent of this. Next, we are having query rewrite node. What this node will do is, lot of times user might give some information, but we rewrite that information so that you will get a efficient lookup when you do the search in the Perplexity. So we actually rewrite the nutrition question to clear search optimized query. So focus on nutritional facts, health benefits, and diet information. So this is the original user message. We convert this into a rewritten query. And then we'll do a search with that rewritten query using a Perplexity. So we use Perplexity search to search the information. And then, as I told, we are using Zep memory store here, where I store the intent, the topic, the user message, and under a particular daily thread. Okay. This is what we are storing. We are logging. The intent is equal to meal log. Then I am going to store, like, role is user, name is demo user, content is this, metadata is this, right? Like this, I'm actually, if the intent is nutrition lookup, I'm actually logging the key insights here. So like this, we are actually logging, whether depending upon the user, we are not logging if user is asking us to compare the information. That is not required because that is only an answer you are supposed to provide. So we are logging only the user meal log and maybe symptoms log and nutrition lookup into this one. So, and then this is a health store node. This is where we store the health data, health logging. Like, if user asks, hey, I'm having some headache today, I'm having some stomach upset today. So like this, you could have a different symptoms. This we made a specific node because this is not user asked all the time. That's why it is specific node added to just to log the health information. Okay. Now we have a retrieval node where we try to retrieve this one depending upon the user query. Okay. So we are querying Zep knowledge graph here, and then the retrieved memory, again we get the fact and then entities. we are just printing here for demo purpose. I'm printing all these things here. What is the facts, what is the entities, and then this memory content will go as the state. Now we want to extract nutrition insights, right? This is the prompt we are making, like, extract 2-3 most important actionable nutrition from this response about this topic. So focus on facts that would be useful for future meal planning and nutrition advice. This is again calling the DeepSeek. And then we are having a summarizer node which will summarize everything. This is most important thing. You can see that before I summarize, I'm getting information from Scratchpad, I'm getting information from memory, the user question, the intent. All of them together will actually use for the summarization. So when you see the prompt, you are saying your health assisting analyze user health pattern data. This is a health history from ZEP. Okay, this is a user question. Then we are saying look at the facts section of the meals data, including meals, weights, and glucose readings. Else you are, if the intent is equal to not recall compare, we are using another prompt. Okay, so this is where the final answer to the user question comes. But if the intent, if you have some like generic information which is not all related to this one, maybe you should be prepared for that. So we'll make it as a quick chat. Okay, next we are going to build our lang graph, nutrition graph. You can see that intent analyzer, query rewriter, perplexity search, memory retriever, health store, LLM summarizer, quick chat. So basically we are means we are storing all the information, right? These are all the nodes. Now entry pointer is intent analyzer. Then we have route by intent, where the intent is equal to health log, it returns this. Like if it is intent is equal to this, return this, because they're all the nodes. You can see these are all matching. Health log, it will be ZEP health store. If it is a nutrition lookup, it is a query rewriter, right? And then we are also adding some conditional edge. Intent analyzer, route by intent, we are having this edge. Now this is a flow. From query rewriter it goes to perplexity search, from perplexity search it goes to ZEP memory retriever to LLM summarizer, and then a route after summarizer is this. And then we are having another conditional edge from LLM summarizer. This is where giving the route after the summarizer. Either you want to store health store or you want to end. Okay. Okay. If the intent is equal to nutrition lookup, we store it. Otherwise, we end it. So we compile the graph, and then we are going to now run this particular agent, and we are just going to run this agent. We can see the create nutrition graph we are creating, initializing the graph here. We ensure the user exists. Then we are just going to run this in a while loop till user enters quit. We will be running this particular graph. Now run this agent. I am running this agent. Let me pull this here so that we can see the full screen. Now we are going to talk to this agent, and then we'll see how the knowledge graph is being built as we talk to that agent. So first, to give this one, I'll start logging my meals. Okay, something like maybe I can say now I ate oats and say berries for lunch, for breakfast. You can see that it is just only, it has analyzed the intent here. The intent, analyzing the intent, it has health log. Okay, and then it is logging that into this one. So it is log, nothing is there here. Maybe next I'll ask the question is something like, or maybe I'll also log, assume that I am also logging, tracking my blood sugar every day. Okay, I also log my weight and then blood sugar. Okay, so I'll say my weight is say around 145 pounds. Okay, so it's analyzing the intent, so it is logging that weight. Now we can also, maybe the user also want to track his blood sugar every day, so maybe he can say first we'll giving all the information so that agent has got the context. Okay, today my fasting is around 100. Okay, I didn't, oh maybe I think I didn't give proper information. It still figured out that uh, it should be glucose. Let's see whether it can, maybe I can add here more details. My fasting blood glucose is 100 today. Okay, now let me ask a question. Is, let's see the table, is mangoes good for diabetes? Now it has to go and then do some research. Okay, now you can see that optimizing query for user research, that was original research. Now it has rewritten the query into nutritional benefits of mango for diabetes, glycemic index, sugar content, dietary guidelines, all those things. Now it is going to do the Perplexity AI search based on that. Now it has returned, it has stored that in the ZEP knowledge graph also, because it has to know like what question user asked in the past after extracting entities and facts. And then now it is using combining research with the personal history, and now it is going to summarize the answer. So let's see what is the answer we get. Now it is storing nutrition insight. So now it has generated this one based on your recent focus in managing. See, because I told in the morning that my blood sugar levels, it is actually saying that this is sentence coming from, because it has got the fact now that you entered some not generic message to you. Okay, but when it is also personalizing advice for you. Okay, and again key takeaways it is giving, because you can see that it is basically just not giving advice. It knows that it is having very personal advice. Maybe it is also saying that your typical meal, maybe because of it is actually having the, because I am using the agent from a couple of days, I entered sometime back that my lunch is rice, sambar and curry. It remembered that. This one is also coming from the knowledge graph, because I have used this previously. Now I can ask a question like, maybe I also log lunch and I'll ask it for my preference for dinner. Okay, so I'll say I had pizza for lunch, so I ate 4 slices of pizza. Now let me log this. This is only help the logging, it is just storing the data. It is not doing any processing right now. Now, I could say, I'd ask question like, suggest me dinner options based on today's breakfast and lunch. Now it has to do the recall compare. You can see that now intent is recall compare, not research. Now it has to the path it is taking is memory retrieval and analysis. Now it has it is going and retrieving this information from the ZEP cloud. So it found from 14 facts and 3 entities. Okay. Now it is, question is suggested me dinner option based, this is what I am asking. Now it is combining research with the personal history. You can see that it is just not getting, it is actually to personalize, it is getting all my previous conversation history. It will build. Now let's see what is the answer we get, whether it is going to build the answer based on what I ate today. Okay, now it has to combine, maybe it might take few seconds. Yeah, now the answer is, it is giving me a couple of options. Let's see whether it has considered my previous, this one. Okay. Now you can see that your history shows a focus on preventing blood sugar spike whenever eating carbohydrate like mango alone, because I told him about my pattern. Okay. And then it is giving me a recommend dinner option. It is giving me option 1, option 2, option 3 and everything. But you can see that it is pulling my previous history. Of course, if you can keep on chatting, it will increase its adaptability because it has got more context. We asked me 3 questions, but if you keep on using for every day, then maybe something like I had stomach upset after eating pizza today. Okay, let me see what happens now. I'm just putting some of my symptom in this. I have not tested this one. I'm testing this flow first time. So now it is just logging a health log. Okay. Let's see now. Asking what should be my break. What should I eat for break? Can I eat pizza for dinner? Let's see, it is able to pull that my stomach upset information when I ask for this question. It's doing a nutrition lookup. Okay, first, and then let's see whether it can pull up my previous information and also generalize a personalized response for that. It is actually doing combining research with personal history. What is a personal history? It is having, again, it found 14 facts in 3 entities it has found. Okay. Let's see what happens next. So now it has to, now in the meantime, you can see the path it has taken. Intent is, it has analyzed intent, nutrition lookup, and then the path it is taking is to do research, analysis and storage, and then it has optimized the query. Okay, you ask this question, it is passing this question to the perplexity. Next, it has retrieved the memory from the perplexity. Now let's see any personalization based on the response. Based on your recent experience and nutrition need, I would recommend avoiding pizza for dinner tonight. Here is why this is best choice for you. Your recent stomach upset is a key signal. Okay, I told I had a stomach upset in the afternoon. It is able to pull that information and then giving me the answer based on that, right? So this is the next after this I'm going to show you how the chat we had just now, how it is being stored in the ZEP memory. So now I log into this ZEP memory. Let's see the sessions I'm having. Oh, this is the demo user. You can, by default I have only one user, so I created that user. You can click on this user and then you can actually see the episodes here. This is what episodic memory, like you can see that every question you have asked, the episodes are available here, right? Oh sorry, okay, sorry, I think I was in the wrong project, my bad. Okay, now I can look into this particular project and then I can see, now you can see that first of all let's talk about sessions. Now you can see there are 2 sessions. So I had one session 3 days back. This is the session I'm having now, right? This is a session. Now you can see the episodes here. Episodes are key in every question I have asked so far. These are all the episodes. Then I can see the graph over here. So this is my knowledge graph. Everything I asked, like it asks about the mango, the information I got from Perplexity research, and then let's see what is, for example, the anything I ask. See my demo user, you can see that my weight, what the food I eat, the beans, you can see that everything is there, all the information is available here. Now let's also go back and see the sessions, right? So what is there in each session? See, every question you have asked today, is available in this session. So it has categorized the who asked this question, like who got the response. So like this is what user has asking this question. The role type is assistant, which is a nutrition agent, right? So and then there was a one session on September 20th. You could see that day what was the session. So now you can see that again the graphs, and this is how basically it stores in the ZEP memory, so that and it pulls all the information regularly whenever based on the user questions. So when asked about the blood sugar, okay, so it linked, it knows that for the mango and blood sugar are related, so it is actually creating that note, no reference over here. Okay, so this is all about the ZEP memory. You can also explore, the whole code will be available in the GitHub repo. You can clone the repo and then start playing with the code, maybe do some changes or maybe fix any issues you find. I'm happy to, and also please provide any feedback on the code. If you see something is missing, something is not correct, please provide a feedback. Thank you.